Hi Data Maniacs, Luis here on another video where I'm super excited to share with you all that I just bring home the TensorFlow Developer Certificate. I've been thinking to get that one for a while now, and I did find some time over the Christmas break, and I just did it. And today I want to share with you how you can do the same. So in today's video, we'll be covering this cheat sheet with everything you need to know before going for the test. Then I'll show you some of the resources that I use it for practicing. And finally, I'll be doing a live coding exercise with a test problem so you know what to expect. As you can see, this is the first English video that I'm recording. If you want more English content, let me know in the comment section. And as always, if you like the video, just hit the like button and subscribe to the channel. Alright, so without any further delay, let's get right to the content. We will be starting by reviewing a cheat sheet that kind of summarizes everything that you can face on the test, at least from my point of view. Even almost all the study session I put down for this certificate has been practical, coding. I've also put together a small cheat sheet to help me navigate through the content and in general keep good mind structure. I think we can divide the exam content in 4 big blocks. General stuff, TensorFlow basics, problem archetypes, which is perhaps the most important block, and then miscellaneous. Let me go through them one by one. The first block is about general Python and deep learning knowledge. You are expected to know how to code in Python. So you should know its basics, variables, data structure, control flows, and all of that. I don't think you need to be an expert, but certainly you need to have the Pythonic thinking inside your brain. Moreover, there are a number of data-specific Python libraries that you should definitely know in and out. I'm talking about NumPy, Pandas, Matplotlib, or even more generic stuff such as CSV or JSON to get your hands around data. Then where you should be practicing. 90% of my time has been spent on Jupyter Notebooks, either on Google Colab or in Cloud VMs. But the test will be actually delivered via a PyCharm plugin. So make sure you are familiar with this IDE. You know how to run scripts, you know some keyboard shortcuts, and in general, you know your way around. So that's all when it's come to Python. Let me move to general machine learning / deep learning knowledge. This is not an introductory exam. The ML/DL basics are taken for granted. You should be 100% familiar with concepts such as train, validation split, the general structure of a deep learning net, such as the MLP, the multi-layer perceptron, the general training loop, with your forward paths, your error and gradient calculation, and the backpropagation on the new weights. You are not expected to be a researcher, but a coder. So before going for the exam, your arsenal should already include tools to deal with overfitting. You should know how to do hyperparameter tuning or apply regularization. All in all, you're expected to be already a machine learning developer. Moving on, let's talk now about our second block, general TensorFlow knowledge. As we all know, TensorFlow is a very comprehensive end-to-end open source platform for machine learning development. It has a very broad ecosystem of tools and libraries from, let's say, reinforcement learning all the way to TFX for machine learning pipelines, or even the recent introduction of graph neural networks. So the question is, do you need to know everything? Answer is, of course, not. This certification is mostly focused on using the Keras high-level API for building deep learning neural networks. Relax, do not, as Keras is pretty comprehensive on its own. You need to master the canonical cycle of building a model, then choose up, optimizer, and loss function, compile the model, and run the training loop via the fit function. So depending on the problem you are trying to solve, make sure you know 3 basic things: the network head topology, the loss function, and the optimizer. For example, if you are building a binary classifier, the network head will be mostly a dense layer with one neuron with the sigmoid activation function. The loss function will be binary cross entropy, and the optimizer will be dependent on the problem. But 80% of the times, the adaptive momentum optimizer, aka ADAM, will be a safe choice. I can't stress this enough. For each problem, know by heart the network head, loss function, and optimizer winning combo. And of course, the metrics to report back, which most of the time will be accuracy, but for the forecasting models, we will see that later on. Now, more stuff. You should know the neural activation functions, with particular emphasis on building the head. So study sigmoid, softmax, and rectified linear unit, ReLU, for intermediate layers. Finally, a couple of specific things that might come handy during the test. Implement callback function to stop training when your reported metrics reaches a particular threshold. That will save some precious time. More likely, you will be building a few models before you hit the jackpot. So a good practice will be to store these intermediate models, saving the weights using training checkpoints so you can restore them later on instead of running the training loop from the beginning. And last but not the least, input shapes. This is something that I tend to get stuck a lot. So practice. Know how to print the training data shapes using, for instance, NumPy shape, np.shape. One thing that I personally do is always add as the first layer a Keras input layer to mentally isolate the shape problem in just one place. The third block is perhaps the most important, and it is focused on particular problem archetypes on three different categories: computer vision, natural language processing, and time series forecasting. Let's start with computer vision, where you will be tested on building models for image classification, both binary and multi-class. The key element to put our focus here will be on the convolution plus pooling layer to extract high-level features of images. In particular, you need to know how the Com2D and MaxPool2D layers work together, how to define the number of kernels, the width and length of the convolution, and padding mechanisms. One classical problem we all face in machine learning is the overfitting problem. So you should know at least two methods to address that in the context of computer vision. One is by image augmentation, using the image generator processing utility of Keras, and the second by killing some neurons using a dropout layer. It might come handy also to know how to use transfer learning to reuse some of the already existing features for a well-known architecture such as Inception v3. Finally, I recommend knowing a reference implementation of a CNN, convolutional neural network, consisting of 3 blocks of 2 Com2D MaxPool2D layers, followed by a flattened and a dropout layer before the network head. Let me switch now to NLP problems, natural language processing, where again, you're expected to know how to build models for text classification, both binary and multi-class. There are 2 big elements to control here: everything related to text tokenization and the concept of embeddings. On text tokenization, you should know how to use the Keras tokenizer class, along with its methods, feed text, and text to sequences to generate numerical representation of textual data. Then, once the text is converted to sequences, you need to know how to operate the Keras embedding layer to generate low-level dimensional data representation or even load pre-trained embeddings. As with computer vision, you are expected to build CNNs with text data, you should know how to build RNNs, or recurrent neural networks. So a canonical net for text treatment can be like one embedding layer at the top, followed by a couple of bidirectional LSTM layers, and then the network head that suits the particular problem you're dealing with. The third block is all about time series, where the problem domain this time is series forecasting. Both univariate, predicting one value, and multivariate, predicting several series at the same time. Nothing else really to add on the net architectures, as we can reuse some of the architecture used for sequence treatment in the NLP block. I believe the key thing to put our focus on will be on data preparation, and in particular using the TensorFlow datasets to generate data windows for training. Let me switch gears now and move to the final block, where I have put a number of other things to consider as well. Data preparation. This is a very broad topic that will be naturally tested on each of the problems to solve. You need to load data. Data can come in various formats like CSV, JSON, TF records, or pre-existing TF datasets. In my experience, the data is almost usable in its natural form, but you might need to do things like time validation splitting, batching, or perhaps some encoding of the labels, or adjust data dimensions to match the neural network input shape. Then, it is also recommended to feel comfortable with some classic introductory dataset out there, like MNIST, Fashion MNIST, ImageNet, or CIFAR. Let me summarize everything you need to know before going for the TensorFlow Developer Certification. Block number 1, Python plus Machine Learning Basis. You should already be a deep learning / machine learning developer. Block number 2, TensorFlow, particular emphasis on the Keras sequential API. Block number 3, 3 different problems domain you should master. Computer vision, image classification, NLP, text classification, time series forecasting. And last but not the least, additional stuff, data preparation, or knowing some reference datasets. Alright, let's start with the third section, where I want to recommend you a few resources that I found super useful to overcome this certification. So if you go through all those resources, there is a high chance probability that you will take the certification home. So we will be covering resources from more general to more specific, meaning the last one are more specific to the certification itself. We're going to be talking about books, courses, videos, and all of that. So as I said on the previous section, this is not a test that you just can go and take it. So you need certain foundations. So first you need to do Python development. You need to have the software engineering fundamental in your mind. You need how to code, right? And at the same time, also you need the basis ML stuff. So for the software engineering fundamental, I'm not giving you any specific resources. I'm having the assumption that you already know how to code. However, if you want to sharpen your Python development skill, I highly recommend you having a look to this book, Effective Python from Brett Slatkin. It gives like 90 very specific way to build better Python code. So, once you have already the fundamentals, it's a good read. It's actually kind of a reference book that you can have it, on your desk. For instance, chapter number 7 about concurrency and parallelism. So if you need to code something about that, it's a good book to have on your desk and have a look or sample code. So, pretty good stuff. Again, it's not something that you will need for the certification, but it's something that in general will sharpen your coding skills. Now, from the ML fundamental stuff, there is this amazing book that I'll show you in a minute, and this is kind of the Bible for this certification. Hands-on machine learning with scikit-learn, Keras, and TensorFlow. This book is just great. This book is amazing. So the second half is devoted to neural networks, but the first half it starts with the basic, with the fundamentals. So you can, if you know how to code, you can take this book and then you can start understanding what is machine learning. Then the first half is more focused on the scikit-learn framework. So stuff such as SVM, decision forest, and all of that. And when you hit chapter 10, it's start really, going deep into deep learning. So, make sure you read the first chapter of this book. This is super good. Now, the book is practical, so it can be the case that you want to go deep into the details of machine learning, so what we call the theoretical foundation. Again, it's not something that you need for this specific test, but if you want to know the basic or the math behind everything, this is the book for you. Deep learning from some heavy names in deep learning such as Ian Goodfellow, Joshua Bengio, and Aaron Kuberville. There are a number of chapters that I found very, very useful. Then the book can escalate in complexity super quickly. It is very math oriented, I would say, so it's not your Sandy read, definitely. But again, there are a number of chapters, and I believe it's chapter 5, machine learning basis, and then chapter 6 that give you the theory behind the feed-forward networks, and then I get like chapter 8 for training loops. Now, once you've covered those bases, once you feel comfortable developing in Python, and what you also feel comfortable with the ML basics, then you can start getting into a specific problem archetype for the certification. And again, the recommended book is the same one, Hanoi Machine Learning with Scikit-Learn Keras and TensorFlow. But then you're going to be focusing on, as I say, on the second half of the book. And then there are a number of chapters which are entirely devoted to problem archetypes. So chapter number 13, everything about loading data with TensorFlow. Chapter 14 about computer vision, as we say, one of the key things for the certification. Then chapter 15, processing sequences using recurrent neural network. So you will go how to implement that on TensorFlow. Then number 16, which is NLP, natural language processing with RRM, and also this second edition is included the attention mechanism, something which is not on this certification, but as you know, it's a big topic those days. Then the book keeps on building on more complex stuff, such as GANs, reinforcement learning, how to put those models into production on the scale. Again, not something that is on the test, but super, super useful for your daily work after you get the certification. At that point, I would say you should be prepared to taking the exam. You have covered the Python basic, the fundamentals of ML, and then if you go throughout that book, and you have to go through that book, developing it yourself, doing the notebooks on the GitHub repo, all of that. You should interiorize all the content in that. And after that, my last recommendation, the more close thing that you can get to the certification, is the Coursera Deep Learning AI TensorFlow Developer Professional Certificate. So I'll tell you, this course is designed and made by very, very same people who are behind the certification. So if you go through that course and everything, you feel comfortable with the code, there is 100% chance that you will the certification. That's for sure. Let's quickly review the content. This Deep Learning TensorFlow Developer Professional Certificate is made up of, I think it's 4 courses. So the first was the Introduction to TensorFlow and Machine Learning, and Deep Learning as well. So it gives you a good refresh of the foundation, but again, you should know that. Then the second course is focused on computer vision using CNNs, convolutional neural networks. Then the third block is about NLP, so natural language processing with TensorFlow, using sequence modeling, the tokenizer, the embedding, all of that. And the fourth one is sequence, time series, and prediction, again, time series forecasting. As you can see, there is almost a perfect match between this course content and the exam guide. So go through this course, do all the notebooks, do all the assignments. And my recommendation is right after you finish the course, do the exam. So I actually did this course, I think it was last year, and then I redo it again before doing the test. So I think you can cover perhaps in 1 week if you go like full gas. But again, take your time to interiorize, go through the notebooks and all of that. Alright, so let's go for the final section of this video where we're going to be coding together an example problem that perhaps something similar may appear on the TensorFlow Developer Certificate exam. So we're going to be focusing on what's just one problem archetype, which is image classification. And for that, I have chosen this datasets. It's actually inside the TensorFlow dataset catalog, so we don't need to download any CSV or JSON. So it's pretty handy. The dataset is called beans. It's actually considered, I think, 1,200 or so images or beans, and one of those beans, it might be healthy or it can have a particular kind of disease. So there are 3 different classes. So it's a multi-class classification problem using images, right? So here you can see, some of the example of the image that we will try to classify, some of the shape of the images, but we'll go to that in a minute. So where do we start? So even the test will be administered via the PyCharm IDE, as we have been discussing. I will actually recommend to start going into a Jupyter Notebook. Why? Because I find that easier to, do iterative programming. Like, you can try to train a few networks. In this case, I'm using a Jupyter Notebook, which is running in a machine with a GPU on it. So if you don't have access to that, you can always go to Google Colab, where you can select that execution environment having a GPU. But in this case, I got it in a VM. All right, so where do we start? So let's start by importing TensorFlow for sure. All right, we start big. There we go. And now we also need to import, in this case, the TensorFlow dataset. So it's like this, as TFDS. All right, what happened to me today? There we go. Now, just remember to be using TensorFlow 2.x. I'm using 2.7 in this case. So, make sure that this is the version you're using. All right, so when you got that, actually, let me put it on the very same cell. I'll try to load the beans dataset. So for that, I just need to get the information from the TFDS. So actually, this thing is called TFDS load. Then you put the name beans, and then I think you need to put with supervised equal to true. All right, so that will be giving me a number of data sets. Actually, if you go back here to documentation, you will see it will return actually a data set with 3 elements. Validation, train, and test is already come split, so that's pretty good. Okay, let's execute that with as supervised. What I'm thinking. Okay, data is getting downloaded now. All right, it's there already. So if we put data set, what do we? There we go. What do we have here? Okay, so we got actually a list with the 3 elements, and each of those elements is a prefetched dataset, so a TensorFlow dataset. Okay, so that's good. I mean, we can choose the second one, which is to be trained. We can choose, train. We got it there. Okay, so let's do one thing. Let's actually do train. Let's actually do train DS, validation DS, and test DS equal to datasets train datasets was validation or valid. Let me check that. It's actually validation, and the last one is test. So datasets test. Okay, so we got already our data, which is split in train, validation, and test. You don't need to use the 3 of them. I don't know what is happening. Sometimes you only need train and test, train and validation. That will be enough. In this case, I got an additional one, but that's fine. Now, one of the things that I do like is actually, smelling the data, being where it is balance, imbalance, before even, training any model. So for that, I can use a number of things here on Jupyter Notebook. But the good thing of this dataset, since it's coming with a TensorFlow dataset, there is a direct integration with the Know Your Data tool. That's, if you don't know, it's pretty cool. I mean, you can see some example of the data, and then the important thing, you can see how the data is distributed among the different labels. So in this case, as you can see, it's almost perfectly balanced. So that's actually pretty good news. And then in terms of the splitting, you can see there is a high number of observation on the train dataset, which is good. And then we should be looking for around 80%, 20% rule of thumb split between train and validation. In this case, it's a bit less. So it's around 13% or, around 13%, which is good. I think we can go ahead for that. So no need to, let's say, to restrict or take any number of elements from that. So data is already good as it is. So let's have a look to those data set. Okay, so that's interesting. As you can see, there are like two different elements, which we were expecting that. So one is the image, which is a array of 500 by 3, so the colors. And then we got an array, unidimensional array, which happen to be the label. So you will need to do some stuff in here. Perhaps let me see whether I can do for in train ds, something as stupid as do that. Okay, so you can see, all right, so data is not, we will need to rescale that a little bit, and then let me go all the way to the bottom. Actually, E of 1. All right, so you can see here the labels 1, 0, 2. Okay, so that gives me a hint that I may need to hot encode that. Okay, so we will need to scale the image a little bit, rescale a little bit. That's perhaps pretty big, and also one hot encode that. So how do we apply transformation to a TensorFlow dataset? So you will need to apply the map function. That's for that we'll do something like train ds scales. That will be where train ds we will apply a map function. We will see which map function we put here. We will see something like pre-process, something like that. We will apply that to the 3 datasets: train, test, and validation. So let's create a function which is called pre-process that actually takes what it takes. So let's have a look. It will take image and a label, right? So image and a label. It will return an image and a label, but the image should be rescaled and the label should be one hot encoded. So let's build that logic in a minute. So I think perhaps the easier one is label one hot encoded. Put here. It is we do have a nice function inside TensorFlow, which is tf1 hot. We pass the label, and there were 3, so yes, 3. So 3 because there are 3 elements, right? 0, 1, 2, and we need to encode it like 0, 0, 1, 0, 1, 0, 1, 0, 0. Okay, and image rescale. So we will do df image resize. We will patch the image and we'll put the new size, perhaps 250 to 50. I think that will be so half. That will be a safe choice. Okay, so that should work. I'm thinking another thing that see the type of that. We definitely should convert it to float32. So TensorFlow doesn't like to work with unsigned integer. And also remember that we need to rescale data, dividing that by 255, the typical thing we do with images. Now, there is a number of ways to do that. You can use image generator, as we discussed on the cheat sheet. We can use some layers in Keras preprocessing layer as well. There is a rescale layer, but I will do it here. So, I can have all the logic in one function. So that's to me is better. So actually, this is image resisted. Let's create another one. Image rescaled. It will be actually as simple as image divided by 255. Okay, we got image resized, and then I think we also need to change the type of that. So image casted, let's call it tf cast image. We said tf float 32 and this here. Okay, that's looking good. So I take the image, run the cast to float 32, good. Then I rescale the image casted, and then I resize the image. I can do that just in one line, but for the sake of reliability, I prefer to do it, one by one. And then which one I need to return? So the last one, which is that one. I just catch an error. This is my rescale. So again, image here, casted, rescale, resize. Okay, this is nice. So okay, then we can map that here. That should be work. Okay, so we map that. Now if we do it like this, okay, you can see. Oh, what's happening here? Okay, what's the problem? So let's run that again. Okay, that's looking good now. That's looking perfect. Okay, so I think we got our data ready for training. What we're gonna do now is start creating the model. So the model, we're gonna create a sequential model. Let's actually that sequential. And then we start adding layers, right? So model add, TF. I like to put always an input layer. I think it's a kind of a good practice to me. It helps, to isolate the shape problem. In this case, it should be pretty simple because we have already defined that. But okay, so that layer basically does nothing, right? It's only add the input. And then let's add, some convolutions, right? That's what you guys was waiting for. So let's have convolution, 2D. So you should know by heart kind of the number of parameters. It's the number of filters. Let's put, 32 filters of 3 by 3. And this is it, right? So the activation is ReLU. I don't need to put it. It's like the default one. And then let me add a max pool 2D, pooling layer. So max pool 2D. Let's put 2. Okay, so that network is looking good. Let's flatten now the stuff to start building the network head. Okay. Okay, so flatten, and let's have the network head. And that's one of the things that now you should know. So we're working with a multi-class image classification problem. So what is the head that I need to put. So this is advanced. How many neurons? 3, because I got 3 different outputs. Which activation function? So softmax, right? So actually let's add some more also a dense layer here, that to build the classifier actually. Otherwise we were just extracting feature. Okay, so that should work. No df here. Conv to d. Oh, I forget layers. That. So layers. Okay, there we go. Okay, so that seems to be good. Okay, next step, let's compile the model, and then let's fill the model. So that's what we need to do, right? For fitting, we just need a number of epochs. Let's put 10, and data. So it's training data, validation data is validation data, of course, and epochs equal to epochs. Okay, so that's good. Now let's build the compiler that where you remember you need 3 things. You need a last function, you need a optimizer, and you need what else? Metrics. You need some metrics. That's that's easy one. Let's put accuracy. Optimizer, I always start with Adam. Again, it's a safe choice. If that doesn't work, you can go for more, start tuning the learning rate and all of that. But I think I clicked insert. Okay, good. But for now, that should be a safe start. And for the loss, so categorical gross entropy, right? Categorical gross entropy. Those are the things that you need to know without thinking. Okay, accuracy. Model compilers actually put just a couple of epochs to make sure the thing is working. All right, boom. Okay. I see. All right, so you can see I'm missing the batch dimension, right? So actually I forgot to batch the data. So let's batch those guys. 32, and now even batching, I'm thinking on actually doing more optimizations. So let's actually prefetch, catch, and all of that. So I just forgot all of that. Sorry. So yeah, let's batch data, and then another thing that we can do is actually catch. So the training loop will be faster. So you don't need to add that, but since the data is a little bit heavy in this case, let's do that. Okay, and now you can see it's a catch data set, which is supposed to be faster. Model is the same, this is the same. Okay, this is working, this is good. As you can see, it's opening the CUDA libraries. That means the GPU is working, so that's good news. Let's see which accuracy we're hitting in just a couple of epochs. All right, so not bad at all. Actually, let's run for 10 epochs. Could it be that with just this very simple architecture we're hitting the jackpot? So is look the case that this is already working very good. You can see we're hitting an accuracy of 96%, and the validation accuracy is 93%. It's pretty heavy, pretty good. So I will call this as a success. So let me do one thing. Instead of running the validation DS, let's run this with test data to see whether we got the same behavior. Yeah, that's in the case that the network is actually learning pretty well that problem. Okay, so let's imagine for a moment that it's not really the case, but let's say one problem that we may be facing is that the validation accuracy is low, right? So we have a high accuracy and a low validation accuracy. That will mean that the network is actually overfitting our data, right? So that means that we'll need to do something for that. So I'll modify a little bit this network to counteract that. So what can we do? So you remember what we discussing earlier. One of the strategies we can do is actually add a dropout layer, right? So this is a very nice regularization mechanism. So let's say 20%. And even another thing we can do is image augmentation. So image augmentation, we can do a number of things. We can actually modify the input pipeline, which is kind of that one. I will not be doing that. We can also use the image generator to flow data, which is retransformed. But I feel like actually adding a couple of layers here that will actually do the image augmentation for me, and that's good. Like get us. They have all a lot of different layers, which is very nice. We have this layer called a random flip. TF curves layers dot random flip that actually flip is, as the name suggests, is random flip the data, and we can flip the data horizontal, vertical, or what I'm going to do, horizontal and vertical. Okay, so that will actually random flip the data. And the other thing that I want to do as well to kind of prevent overfitting, which I just say is not the case, but is do a random rotation as well. So random rotation, and then here you put the rotation that you wanna do. Let's say 20%. So that will be our new model. What's going on? Yeah, I'm pretty sure it was like that. Let me actually look for that. Yeah, it's there. So let me see what may be happening here. So copy. Did I write that bad? What's going on? All right, so that might be the version that I'm running on TensorFlow. It's not the version that I need. Let me see, print TF version, so we come handy. Boom. You can do this on the test. That's the nice thing. You have the internet open, so that's nice too. Oh boy, I knew it. So let's do one thing. Let's do pip3 install tensor flow equal 2.7.0. I thought I was running 2.7. It seems not the case. So anyway, so let's install it. Again, you can see you can go to the TensorFlow documentation. You can go Stack Overflow. Make sure you make use of all of that, because that will go pretty handy. Okay. Oh boy. So I have to put minus user. It seems I don't have the right permission on that machine. No problem. I will install with that, with minus user. I will say I will need to restore the kernel after that. All right, we're back here. So there was some problem with the kernel, so I had to restart the entire thing. But anyways, it's coming back good. So 2.7, that's what we were expecting. Let's actually rerun the entire thing. All right, let's get that. Let's the pre-pros. Let's that's good. Let's skip that, as we we are with this second model. Should work now. Okay, you can see this is getting the those layers. Okay, now they may be a recent introduction, not sure in which version, definitely not in 2.3, but they are indeed in 2.7 as we just saw. Right, so that should be exactly the same. We didn't change the head. Let me put it in just one cell. Actually, let me add a new one here. All right, so let's compile the thing. Boom. I mean, the results, they were really pretty good. It might be the case that the initial epochs are actually worse because we are adding some regularization. But if we were hitting some overfitting problem, which again is not the case, we can do that, right, to counteract that problem. So right, so the first one, let me check, 45%, 47%. It's actually like a big distance from that. I guess this is due to the dropout layer. I guess it should get increasing. Okay, so that may take some time, so let me stop the recording and I'll be back in a minute. So the training just finished. I actually changed the number of epochs to 20. As you can see, the accuracy getting on increasing, but it almost reached 70%. But as you can see, the noise introduction effects of the random flip and rotation layers doesn't work in favor of accuracy in just 20 epochs. So my hypothesis is if we run this for 50, 60, or even 100, we eventually will see the same accuracy numbers. But just use these regularization tools when needed, which as we can see, this is not the case. Again, in just the 10 epochs, we quickly hit the 90% plus accuracy, so not needed. But anyway, so I want to show you just one final way to train the network, just in case you may train this initial network that doesn't work. You add more com to the max pool to the layers. You even increase this dense layer to 250 seed or 512, even what's this 24, and that doesn't work either. So what else can you do, right? So let's focus now in transfer learning. We're gonna be using one already pre-trained network with like a lot of data, and how can we actually leverage that feature extraction backbone to build a new network, right? So let's do that. So how we do that? So let's call it pre-trained backbone. It is we have this nice repository of already pre-trained models, which is the TF Keras applications. In this case, let's go use this. So let's actually have a look. Here we go. So those are all the things that we got. Let's actually use that one, Inception v3. So let's get the name. All right, so I think this is capital letters. So I think the parameters is the weights. So in this case, let's use the one from the ImageNet datasets. Whether to include the top, in this case, no, because we're gonna customize that. Include top, yes, false. And finally, let's get the input shape that we have already prepared back here. It's that one. All right. Okay, so with that, we will actually be downloading the weights for that model. What do we need to do now? So basically, we will need to add, after this model, some of the layers we were using. But before that, what we need to do is freeze all the layers so they are not trainable. So basically we do for layer in pre-train backbone layer dot try enable false. Try enable. Okay, so if we do I just changed the name. I know I put a backbone before, but I was messing with some scene before, so I just changed the name. But the same pre-trained model dot summary should be pretty big. Let's have a look. Yeah, that one is pretty big. So the idea now is to add a few more layers at the end. So you know they are kind of fine-tuned for the problem we're trying to solve here. So okay, so let's do that. Let's again put the input layer. I think that's a kind of a good practice, at least for me. Definitely input shape. What we're expecting 250, 253. Okay, so we have the input layer. Now let's actually put the x equal pre-trained model, then input layer like that. Okay, and now let's stop staking layers on that. So what else do we need to staff? So flatten layer, I guess, after the convolutions, flatten like that. Remember, this is the functional API, so I'm just stacking layers one after another. So this and then after that. So to me, it's a bit counterintuitive. That is all the way around, but here's the way it is. Now let's just put the dense layer that will actually be learning the classification. We'll be using all the features. I think we put 128, and finally let's just put the final classifier, which is a 3 with the activation soft max. Boom. So that model should be good to go. Let's copy and paste the compile and fit. This is compile and the fitting as well. Here we go. Okay, now what we're doing here, so again we're using a pre-trained model, extension v3, where we're actually reusing all the features that is extracting, and then we just add the initial input layer. I mean that can be a skip, but again it's something that I like to do really. And then after the model we add these fine-tuning layers to make sure it fits or suits to the problem that we're trying to solve. Okay, so let's run the training. Hopefully the accuracy should be good here, because we are reusing a lot of good feature in the model. It seems good. So just on the first epoch is almost 80%. So let's finish and let's wait for those 10 epochs. So I'll come back in a minute. Alright, so training is about just to finish. This is the last epoch again, so very good number, very good high accuracy, 99% in both accuracy and validation accuracy. Which is in line with the first model. But anyway, though, I just want to show you another way to deal with problems. Anyways, as you can see, we've been doing everything in a notebook, and that's actually my recommendation, because normally you have access to GPUs, so it's easier to go back and forth here. You can see all the problem we have with the TensorFlow version, and once you got your model fine-tuned, you can just simply go and move to PyCharm. Basically, you will have you create a pattern file here, so image classifier, and then basically it's a copy and paste exercise really. So let's do that very quickly. So I add this because I was doing some tests. We don't need that, right? So let's put that here. This as well. this as well. The preprocess function, let's put it at the top. This as well. Yeah, just let's go with the first model. That actually worked out pretty good. And the compile and what the fit here. Okay, so anyway, so let's actually add a bit more structure. So def, let's call train model, whatever. Let's get a function here. It must more neat, I guess. Okay, basically when the model is fit, this model is a return model. Basically, let's put here if name let's go train model, no model one train model and model p to save. All right, so we just add some structure to the code, as you can see, but I think you might expect something similar on the test. So let's run this. There we go. Good to know some shortcuts as well. You can see we basically, running that function that basically train the model and save the model. Now it's downloading the data. I mean, it will do exactly the same that we did in the notebook. But now you come to PyCharm with certain guarantees, right? That the process already work. So you can see it's training here. Again, so let's wait until the finish. And with that, we will be ending the video. So be right back. All right, so I'm back here. The model is just about to finish, or is already finished. There we go. Very good accuracy, we were expecting from the notebook. 90% on the validation, 96% of the accuracy on the training set. So very good stuff. And even you can see our model has been saved here. So we can call this finish, I guess. And that was really all I want to share with you in this third example. That was about today. I hope you guys enjoyed the video. If you happen to use this material and you pass the exam, just let me know in the comments. Very keen to see whether this was useful or not. If you have any doubts, any comment, again, just leave me a comment. I'll try to allocate some time and go through all of them. And again, thanks for watching. If you did like the video, just hit the like button. And if the content that I'm uploading